we are going to just sample little tiny bits of 16.5 and 16.6. We've talked about a strong acid, right? A strong acid is one that dissociates. So in a strong acid solution, the concentration of the hydrogen ion is the same as the concentration of the acid. There's no difference. And so to find the hydrogen ion concentration of a strong acid, the concentration of that acid is the same as the concentration of the hydrogen ions. And so we just use our pH formula. If we have 2 molar hydrogen ion concentration, then what's the pH going to be? Well, it's going to be the negative log of 2. I need a calculator. So if we take 2, the log of 2, and change the sign, we get a pH of negative 0.30. And that seems like it's off the pH scale, but it is possible to have some negative pHs. We won't do those on exams, though. So let's do an example like this. Consider an aqueous solution of 2 times 10 to the minus 3rd molar HCl. The examples we were doing on Wednesday, we said, here's the hydrogen ion concentration, or here's the hydroxide ion concentration. This example is saying, here's the concentration of the acid. You can only predict this easily, the pH, with a strong acid. The good news is I'm only going to ask you about strong acids. So if we see this HCl, the concentration is 2 times 10 to the minus 3rd. Let's write this out. So the concentration of HCl equals 2.0 times 10 to the minus 3rd molar. That is equal to the hydrogen ion concentration, because every molecule of HCl will produce 1 hydrogen ion. So the concentrations of these are the same. So then to find the pH of this solution, the pH is the negative log of the hydrogen ion concentration. So we just plug the number in, 2.0 times 10 to the minus 3rd. On the calculator, 2 times 10 to the minus 3rd, 2 EE minus 3. Press the log button, change the sign. I'm going to round that. My calculator is showing me 2.698970004. This number has 2 significant figures, so in my pH I'm going to give 2 decimal places, so that rounds up to 2.70. I'm showing you how to do significant figures. If you don't understand sig figs and pH, you'll be fine on the exam. There's nothing on there that's going to try to trick you over that. So don't worry about it too much. Any questions? How about calculate the pH of a 1.5 times 10 to the minus 11th molar solution of HCl? Well, this is exactly the same idea, right? Here we've got HCl. Oops. We've got HCl. That's a strong acid. So the concentration of hydrogen chloride is equal to the concentration of the hydrogen ion, which equals that. So then the pH is the negative log of 1.5 times 10 to the minus 11. or 10.82. Do your calculators remember how to do that? We spoke to some of them on Wednesday. Straighten them out. But maybe they forgot. It's been 2 days.
Minus 10.82.
Right, and see this negative sign here? That means you have to switch the sign.
I did.
Oh, you did? Okay, let's double check that then. So here's another one. Let's try this. Okay, calculate the pH of the solution of nitric acid. Nitric acid is also a strong acid. So the pH will equal the negative log of what?
1.5.
1.5 times 10 to the minus 2. So that comes out to 1.82. Make sure your calculator understands. It's not your fault, right? It's the calculator's fault. Any questions? I'm going to give you this equation. This pH equals negative log of the hydrogen ion concentration. That will be on the sheet of useful information. But as we've seen, applying that equation is not as straightforward as it seems, because calculators want you to put the numbers in different ways, and so you do have to practice it a little bit and make sure that you're coming up with the correct answer. That appears to be the end.